Okay. Two-dimensional signal space. So, so now we're going to have, instead of just a one vector S, and everything being in this direction, now we're going to have two vectors, Sx and Sy. They're going to be orthogonal to each other, and they're both going to have norm 1. So basically what this is going to let me do is, instead of simply putting points along this line, I can still do that, but in that case I have a 0 component in the y direction. Now I can have components in both the x and the y direction. So in fact I can put signals on a two-dimensional plane like that. So for instance I could do this. In Fourier. So what we need are two basis signals. Sx and Sy with, or both have unit norm. So norm of Sx is equal to norm of Sy is equal to 1, and Sx dot Sy 0. Okay, Sx dot Sy equals 0. That means they're orthogonal. Sx and Sy's norm equal 1. Then they've both been normalized. What do we call such a basis? If X orthonormal. So this is an orthonormal basis. So each signal in the signal space is composed of a component in the direction of Sx and a component in the direction of Sy. So now, the signal vector Si is equal to alpha I Sx plus beta I Sy. So, for instance, if I have my basis here, Sx, Sy, that's orthogonal, and I have, let's say, Si is equal to 5 Sx, actually let's say minus 5 Sx plus 2 Sy, and what do I have? My signal point is then 1, 2, 3, 4, 5, minus 5 in the x direction, and plus 2 in the y direction. So Si would be there. Question?
What does a 2D signal physically mean in terms of voltages when you're sending it?
So for instance, as long as Sx and Sy are orthogonal, you can pick those two signals however you like. So one example would be this. Sx, like that, so that's 1 over root NB, up to NB. Sy, let's say this is, let's say NB equals 8. Sy look like this. Up to 4 and up to 8, where all of these are 1 over root NB, and these are minus 1 over root NB. Actually, let's take a second and do an example. It's a good idea. So let's let Sx be this, and Sy be this. So each signal is composed of some linear combination of those two. First thing I'm going to do is I'm going to show that the norm of Sx and Sy are both 1, and then I'm going to show that they're orthogonal, and then I'm going to show you some signals composed of the two of them. Okay, norm Sx. Easiest way to calculate that is take Sx dot with itself. Take the square root. So Sx is just 1 over root 8. Root 8 from I equals from k equals 1 to 8. So that's 1 over root 8. That's 1 over root 8 plus and so on 8 times, which is 8 times 1 over 8, which is 1. And the square root of that is just 1. So therefore Sx is normal. So that's cool. Norm Sy is root Sy times Sy dot Sy. So we have 4 examples where it's 1 over 8 times 1 over root, or 1 over root 8 times 1 over root 8. So these 4 are 1 over 8. And we have 4 examples where it's minus 1 over root 8 times minus 1 over root 8, which is again 1 over 8. So that's again 8 times 1 over 8. 1. So that's normal. That's normal. And now we have to check that they're orthogonal. Sx dot Sy is, what is that? Well, we have the first 4 elements. We have 4 times 1 over root 8 times 1 over root 8. So the first 4 elements of both are 1 over root 8. And the last 4, the x's are 1 over root 8, and the y's are minus 1 over root 8. So basically I have 4 times 1 over 8 times 1 over 8 minus 4 times 1 over root 8 times 1 over root 8, which is 0. So yes, they're normal, and they are orthogonal. So that's all good. What does a signal look like? A signal looks like this. Let's say S0 is equal to 1 times Sx plus 1 times Sy. In that case, what do I have? I have Sx, which is this, plus Sy, which is this. So for the first 4 elements, these 4, I'm adding, basically all of these elements I'm adding, let me actually draw it out. To each of these elements I'm adding 1 over root nb. These start out as 1 over root n, 1 over root 8 here. These are minus 1 over root 8. And these are all plus 1 over root 8. So for these 4 elements, the addition becomes 2 over root 8. And for the next 4, it's minus 1 over root 8 plus 1 over root 8, which is 0. So that's what it looks like. And you can compose them any way you like. So for example, and it's worth bearing in mind, remember our analog to digital, or excuse me, our digital to analog strategy. Basically, all we do is we cover off those like that. So that's voltage-wise.